Hi, Roy Treveline here, Biology Bites. Today we're going to talk about a process called eutrophication. I want to show you Crater Lake. It's out in Oregon, and it is deep and clear. That's not the sky in that picture, that's the lake, right? There's no nutrients. And we're going to use a term called oligotrophic. Oligotrophic lakes have no nutrients. Geologically speaking, it's a brand new lake, only a couple million years old. What happens over time naturally is lakes go from oligotrophic to eutrophic. They gain nutrients. And eventually, it's a small enough lake, it'll become land, right? Now, there's a problem, and it's the same problem we've talked about before. I try not to put too much nitrogen on my grass, although everybody does, because they want nitrogen because it makes the grass grow better. Does anybody remember why? Mrs. Treveline?
Protein and DNA.
Protein and DNA. Nitrogen is necessary to make protein and DNA. You need both of those structures to grow a cell, right? That's the first number on the fertilizer box. That 20 there is representing 20% nitrogen. The second number on that box is phosphorus. And both nitrogen and phosphorus are what we're going to call abiotic limiting factors. Limiting factors, remember, are going to control the population growth. If a cell does not have nitrogen and phosphorus, it can't grow. Well, here's the problem. We are putting so much nitrogen and phosphorus on our grass or on our crops that it's causing what we call cultural eutrophication. And today, for your sake, for your academic pleasure, I am going to go into a eutrophic pond. It's going to fill up, it's going to smell, it's going to be very disgusting. I'm doing it for you, okay? Because we're going from oligotrophic to eutrophic. What to do? Stop putting so much nitrogen and phosphorus on the grass. Those first two numbers on that fertilizer bag are what is representing that, right? So if we look down here at my grass, I'm going to come and put nitrogen and phosphorus, fertilizer. Maybe you got a company that comes and does that, or maybe your dad puts nitrogen on the grass, right? That nitrogen on the grass is washing off into those ponds. And what would normally be a clear pond is going to be really gross today. Really gross. I'm going to have to take a shower gross. Here's what happens. The nitrogen and the phosphorus were not in the pond, so the algae didn't grow. Now, all that nitrogen washes off and the pond is filled with algae. This cyanobacteria, we talked about it once before. Some of you got it in your ecology bottles, on the bottom of your ecology bottles. And it gets very, very gross because it's growing exponentially. You remember exponential growth? Really rapid. It was that J-shaped graph because it's multiplied by the number of individuals. Starts off slow, but it gets really bad, right? So maybe you got a pond or a lake that looks like this. It would be a great example of eutrophication, right? A pond that is filled in with all those nutrients. And it's cultural eutrophication because we did it, right? We're putting too much nitrogen and phosphorus. Now you might say, hey, Mr. T, algae, they're green. They're producers. Aren't they doing photosynthesis? And in photosynthesis, you produce oxygen. But there's something really important to remember. That's this phrase way down here. Mrs. Treveline, you might have to get lower. That's that important of a phrase. Plants do respiration. Those plants are sucking up oxygen, especially at night, more than they're making during the day. And because of that, the pond is going to die. Any animals in that pond are going to die because the algae is choking the oxygen right out of those ponds, right? What should have happened in those ponds, as the algae grew, one of these limiting factors would keep it from growing, nitrogen or phosphorus. Why was nitrogen important again?
Protein.
Protein and
DNA.
DNA. Why was phosphorus important? Makes up our cell membranes, okay? These are the limiting factors that I want you to know. We're going to just keep coming back to these. Remember, we saw them in the compost pile. We saw them in the dog poop. Where else did we see them? Fertilizer box. Oh, it's important. You got to know that. And what's going to build up in those ponds is this term called detritus, which is just basically waste products, dead animals, poop, right? Let's go act like we're nitrogen. I'm going to start on the grass, and I'm going to wash off into the ponds, and all of a sudden those ponds are going to fill with algae. They're going to grow exponentially. Why? Because there's no longer a limiting factor. There's no longer any control of the amount of nitrogen they have. Right? How are we doing on time, Mrs. Treline?
5:15.
Oh my goodness, we're doing great. All right, so fertilizer goes on the grass. What two big ones? What's the first two numbers on the fertilizer box? First one is?
Nitrogen.
Nitrogen. Second number is?
Phosphorus.
Phosphorus, right?
Woohoo!
Those are the two limiting factors we're looking at, right? That make your grass greener, it's going to make the pond greeners, unfortunately. And that process is called cultural eutrophication. Let's go look at the detritus. Let's go look at all that stuff. So here I am. I'm nitrogen. I'm washing off in the shore. Come on down, Miss Treline. Join me in the pond, right?
No.
I'm coming. I wash here. And all of a sudden, I'm in the pond. Look at all this. Look. Oh, there's gross flies. Oh, it smells in here. Oh, no. Don't fall in.
6.
All right? This is eutrophication. Right? There's dead animals, the oxygen sucked out. This is gross. This is not what our pond's supposed to be like. Over time, this will fill in. Now, this is probably an artificial detention pond, right? But, oh, I think something just bit me. But the fact of the matter is, they'll have to either dig this back out or it's just going to fill in. This is doing respiration at night. You see it? It's making oxygen now, but it sucks all the oxygen out at night. And that's what's going to fill up those ponds. I'm Roy Treline. These are Biology Bites. Please comment, say like, or subscribe, or all the above. Thank you.